Hi. So in the last video we had talked about what econometrics is and what is an empirical analysis. In this video we'll be talking about types of economic data. Okay, so in the previous class we had talked about how economic data is really important for our empirical analysis, or how economic data forms the base for econometrics to help us analyze various economic theories and uh, test their relevance. So we'll talk about the types of data that exist and what are the classification of the data of those data. Okay, so let's start. So basically we have four types of economic data. Okay, so the first type is your cross sectional data. Then we have your time series data. Then we have your pooled cross section data, and the fourth one is your panel slash longitudinal data. Okay, so these are the four types of data that are available for a econometrician, and we'll try to discuss each type of data individually. Okay, so let's start with the first one, that is your cross sectional data. So in the most simple form, cross sectional data means data is collected on many units at a particular given time. Okay, so we have many variables on which data is collected at a given point of time. So for example, uh, suppose suppose we have 10 firms which are listed in the stock market. Okay, so if I collect the closing stock price stock price of these 10 entities entities enti sorry entities on a given day, then this becomes my cross sectional data. So we have multiple data points on a given time. Okay, so that is your cross sectional data. So when it comes to cross sectional data, your time is not a very big factor here. Like you can choose any time frame that you want to choose, so time is not relevant. So what is relevant here is the data points or the entities that you have chosen. So that becomes your cross sectional data. So the second one is your time series data. Okay, so this is fairly simple. So you take data point on a single entity. So you collect data on a single entity over a period of time. So this is time on the x-axis, and this is your variable, say y, whatever. Suppose this is the data for the GDP of India. So you collect the data of Indian GDP over multiple time frame, and you try to see a relationship there. Okay, so whether the GDP is rising or it's falling or it's stagnant, whatever. So you are collecting data on a single entity over a period of time. So that is your time series data, right? So in the case of time series data, your time frame is important. Time frame is important. Okay, and there is usually a stretch of time over which you are observing the data of a particular variable. Okay, so that is your time series data. So, and usually what happens is, usually your data at different time frames can be correlated. Okay, so the GDP that we have in 2023 can be correlated to the value of GDP in 2022 due to multiple reasons. So we will talk about correlation and causality in a different video. So this is just to make you understand what time series data is. Okay, so this is your time series data. Now let's move to the next data type of data, that is your, sorry, pooled cross sectional data. So when we are when we were talking about cross sectional data, we mentioned that we collect data on multiple entities at a particular point of time. So in the case of pooled cross sectional data, what happens is you are collecting collecting data on multiple entities over multiple period of time. Okay, so this is different from time series in the sense that the data points that you are collecting is of multiple entities, and also the time period here is not a stretch of time. Okay, so it doesn't have to be a continuous time frame. You can collect data on different time frames. Like suppose you collect the data of GDP of data of GDP of 10 countries, okay, in 2000, 2000, 2005, 2009, 2011. Okay, so this can go on in this fashion. So collecting data on multiple entities over different time frames or different point of times. So let me just, multiple, cut this word here, period, and instead write, sorry, let me use a eraser. So multiple point of time. So this is your pooled cross-sectional data. Okay. So pooled cross-sectional data is important in order to check the effectiveness of a policy intervention. So supposingly, uh, we have the data of the fertility rates of India in 2010. Okay, now, or not just India, say 10 countries for 2010. Now, suppose the UN brings up a policy wherein it tries to control the fertility rates by uh, providing free contraceptives in all these 10 countries. Okay, so we will check what was the impact of this policy, and we'll reanalyze the fertility rates, suppose in 2015. So over the period of 5 years, how has this policy performed can also be checked through the pooled cross sectional data. Okay, so this was about pooled cross sectional data. So let's move ahead to the fourth type of data set, that is your panel data. So panel data is it's also called longitudinal data. Okay, so it basically is a combination of your uh, cross sectional data and time series data. So it is collecting data of multiple entities over a stretch of time. Okay, so it's like collecting the GDP of any 10 countries over a range of time, that is you can say from 2010 to 2020. So that becomes your panel data. So one thing I forgot to mention in the case of, let me go back, in the case of uh, time series data, is that the variable that you have taken and the data on the variable that you are calculating remains fixed. So if suppose you have taken the GDP of India and you are checking how it has performed over the years, so that thing would remain same. So you will always take the value of Indian GDP, not of any other nation. Okay, so this is the case, and similarly this goes for your panel data also, that whatever entities that you have chosen, whatever 10 countries you have chosen, or the GDP of 10 countries that you have chosen, you'll continue to take data sets on the same 10 countries over a period of time. Okay, so that is your panel data set. So this was about the types of data sets. I hope it made some sense to you. So in the next discussion, we'll talk about correlation and causality. Thanks.